our next speaker and the last speaker of our SBC session is Mr. Sushma Shamanto from Radio Physics and Electronics University. Mr. Shamanto, have you joined? Yeah.
Yeah, Devi, can you listen to me?
Yeah, I can listen, but I think we have to do some other adjustment. So first,
Okay.
I'm just reading his bio. Mr. Sushma Shamanto is a research scholar in the Institute of Radiophysics and Electronics, University of Calcutta, India. He is a professional member of IEEE Antennas and Propagation Society, the European Association of on Antennas and Propagation, and the European Microwave Association. He is currently working in the research areas of 5G and 6G antennas, low Earth orbit satellite antennas, IoT, RFID, wearable antennas, CV2X automotive antennas, and biomedical antennas. Since 2015, Mr. Shamanta has been volunteering for peer-reviewed journals and conferences of repute as a reviewer and an associate editor. He is the recipient of Best Reviewer Award 2018 by Radio Engineering Journal in Czech Republic. So, with this brief introduction, I would like Mr. Shamanto, please proceed.
First of all, thank you, Devi, for such a nice introduction. So I would like to share my screen. Is the screen visible, Devi?
Yes, yes, we can
Okay,
see
fine.
you and also your screen.
So, hello everyone. I'm Shushamoy. I am a research scholar under Dr. Kaushik Mondal from Radio Physics and Electronics. So, from today morning, we have listened about several modern applications of antennas, several design aspects, several methodologies, and we are really delighted of knowing new concepts about antenna design. So this is my first kind of experience of presenting at such an young scientist conclave. So I'm excited, also a bit nervous. First of all, I would like to thank Ms. Devi Dotto, who actually contacted me for this presentation. And also I would like to thank all senior members of Kolkata APS MTT chapter for allowing me to present this. This presentation would be a bit different from the traditional technical presentation because in this presentation, I have planned to showcase something different because I have thought that when a PhD scholar or the people who are about to finish their PhDs and looking for a job, they almost get confused that in which domain they must pursue their research or in which domain they need to be upskilled or reskilled. So I would like to try my best to get an overview regarding the current trends of antennas. So my presentation will start with the antenna market forecast, followed by the emerging technology phases, then the strategy to choose a trendy research area, and the antenna linked emerging technologies from 2016 to 2021. Then the antenna linked job keywords present in published in recent times, and the immediate challenges and the possible solutions. My presentation will conclude with the takeaways from the presentation. So this is the current antenna market forecast conducted by the Modern Intelligence company. So it witnessed a shipment of 18.1 billion antenna units in 2020 when we were going through the lockdown in major countries all over the world. And then in the beginning of the Industry 4.0 or the fourth industrial revolution, several analyses are going on. Based on that, the Modern Intelligence expected the shipment of 30.84 billion antenna units in 2026. They expected that, which is having a 9.72 CAGR over the forecast period of 2021 to 2026. The fastest growing market is going to be the Asia Pacific, which is interesting. And the largest market would be the North America. Now, for any market of any product, the researchers play a vital role. So, before we get involved to any kind of research, be it at PhD level, postdoctoral level, or industrial R&D level, so we must know that which area we must focus on before we start any research. The Gartner hype cycle helps here a lot. So Gartner is an America-based technology research consulting company. They publish this hype cycle every year. So what is that? Hype cycle predicts the development of any technology starting from the innovation phase to the productivity phase. There are total 5 phases. The first phase is the innovation trigger. We think about something. We have several problems and we think about something to resolve that issues. And that is the beginning of R&D. In the next phase, when several experimentations goes on, we publish some papers, we present at some conferences, there is some hype in the industry, in the media. So this phase is called the peak of inflated expectations. More research goes on, and at the same time, several failures are also being reported. So the hype comes down, and this phase is called the trough of disillusionment. In the fourth phase, more advanced research is carried out, and we get some more scopes of correcting the errors to make more perfect for the human use. And finally, in the fifth phase, the productivity begins. So if I make a summary of these 5 phases, so we get a concept that from this trough of disillusionment to the plateau of productivity, this may be called the production phase, which is taken over by the industry. And starting from the innovation trigger to somehow up to trough of disillusionment and the slope of enlightenment, in this phase, basically the main R&D takes place, and which is the place for the researchers. So that is why before we begin our research, we need to know when we are focusing on any technology and we are planning that we are working on this technology, we must be aware about the current phase of that technological development. Now, how to strategize to choose a trendy research area? What should be our strategy? How to do that? Now, here I declare that this strategy is my idea. So there is no published article on which I am talking about. This is my idea only. So first of all, mark emerging research topics from this technology trigger phase and the peak of inflated expectation phase, because in this phase, actually, as you can see, if I zoom out the regions, the startup companies are investing their capitals, and there is some interest among the public, so that we get a lot of funding to initiate the research and to publish our results as well. So that is why before we start our Before we start, we must focus on these two phases, technology trigger and peak of inflated expectation. Now the step 2 is link broad research area to an emerging research topic. So I'll give an example so it will be very clear. And the step 3 is you make your emerging research area in this way. First, say our broad area is antenna design and an emerging topic is flying autonomous vehicle. So we will see this topic after some time. So our research area can be the antenna design for flying autonomous vehicle. So in this way, we can set a trendy research area. But we need to work a bit in detail before we conclude so easily. So first we take the Gartner hype cycle for last 5 years, 6 years, 7 years as per our wish. As the time constraints, I am just displaying 2016 to 2021 so that we all get an idea that how the emerging technology changes year by year. So this is the Gartner hype cycle for the year 2016, and you may see there are several technologies like smart drugs, 4G printing, and so on, IoT, here virtual reality. So there are several technologies listed here. So Gartner company, they also predict the lifetime of different topics. For example, here the gray circle, I'm zooming it again. For example, the gray circle means this technology is going to last less than 2 years. The light blue is 2 to 5 years. The dark blue is 5 to 10 years. And the orange is more than 10 years. There is no fixed color code. For this, they have used this color code. For the next year, they may change the color code. So this is the idea. Now, if we mark the antenna linked technologies from this plot, so we can see there are several topics. The first topic that I have found is 802.11ax, which is called a Wi-Fi 6. So definitely this is an antenna linked emerging technology, and the life expectancy is 5 to 10 years. So we can definitely work on it. Then smart workspace, commercial unmanned aerial vehicle or drones, IoT platform, smart robots, connected home, autonomous vehicle. So all these emerging topics can be linked to antenna, and we can set our emerging antenna research area. Next, for 2017. In 2017, the 5G comes in the R&D phase with a life expectancy 5 to 10 years. Smart workspace, smart robot, IoT platform, connected home, autonomous vehicle, and commercial UAVs, they are existing. Probably their life expectancy has changed due to several factors. In 2018, this flying autonomous vehicle comes with a life expectancy more than 10 years, and the autonomous driving level 5, it has also life expectancy more than 10 years. Smart robots, autonomous mobile robots, smart workspace, IoT platform, connected home, and autonomous driving level 4. So we are getting a lot of new topics in 2018 where we can link antenna and move forward with a new emerging research topic. In 2019, the flying autonomous vehicle again is showing more than 10 years life expectancy, and the light cargo delivery drone comes with a life expectancy of 5 to 10 years, and the low Earth orbit satellite systems 5 to 10 years life expectancy, and we are seeing a lot of antenna related publications on low earth orbit satellite antennas. So this is an example that how they connected the emerging technologies with the antenna design. Then autonomous driving level 5, 5G, autonomous driving level 4, they are still existing. In 2020, uh, this flying autonomous vehicle, robots, and all these topics, they disappeared in 2020 when the lockdown started and the industry moved towards more automation. Um, so definitely the AI assisted design, low cost single board computers at the edge, biodegradable sensors, and private 5G, these topics emerged as some antenna linked emerging technologies. So even if it is AI assisted design, so we must think about how we can convert our antenna knowledge into this AI assisted design. Several antenna simulators are adapting AI assisted design in their simulation. So in this way, we must think about that whether we can make a biodegradable antenna, as the biodegradable sensor is the emerging technologies for the year 2020. So in this way, then the last report by the Gartner is the emerging technologies for the 2021. So here the AI augmented design. So AI augmented design means artificial intelligence with more human features. So we need to think about whether we can link our and the knowledge of antenna design to AI augmented design, and we can create some device, wireless device. So we may think about that because they have just in the triggering phase here, in the triggering phase. And then AI driven innovation, the real time incident center as a service. So we can think about some new research about new developing new antenna for real time incident related applications and the employee communication applications. The literature may not be available, but we can think about that how we can link our antenna knowledge to these employee communication applications so that we can get involved into some pioneering research, because these topics are just at the innovation trigger phase. There might not be literature, journal papers, there might not be conferences organized, but they have several scopes to work on. Now, the anti-learning job keywords that is collected from the LinkedIn job search, scholarshipdb.net, and the UXS website for PhD and postdoctoral research and for industry. So for PhD and postdoctoral research, the most important keywords or most common keywords was the multi-antenna communication beyond 5G and 6G, the millimeter wave antennas, the terahertz antennas, massive MIMO, cell-free massive MIMO, beam space massive MIMO, active antennas, smart antennas, and multiple beam hybrid array antenna for satellite communication. So these keywords were found mostly in the PhD or postdoctoral research advertisement. However, in industry, they are looking for the research and
Excuse me.
development. Yes,
Excuse me. You
yes,
have 5 more minutes.
yes, I'll be finishing soon. Thank you, Dev.
Yeah, yeah.
However, in the industry, we are getting the keywords like phased array, deployable antenna, antennas for smart farming, smart city, smart factory, the dual band 77 140 gigahertz automotive radar antenna, distributed antenna system, onboard aircraft intelligent antenna, the antenna for unmanned aerial vehicle, internet of things, tactile internet, and the antenna for the vehicle to anything antenna in cellular communication, the device to device antenna, machine to machine antenna, the enhanced mobile broadband antenna, the MMTC URL LLC. There are several applications like that. So these keywords, knowing the keywords are important before we uh, jump into any PhD, postdoctoral research, or applying for industry jobs. However, there are some immediate challenges, like we have limited accessibility of high-end fabrication facility. We might have the limited accessibility of industry grade measurement facility. Say I want to conduct an vehicle mounted antenna and I need such a big anechoic chamber that can accommodate a big vehicle, but immediately that may not be possible. Then limitation of computing hardware resources, because when I am simulating some complex structure based on my idea, the simulation is becoming resource extensive and my computer fails. So in that case, I need to look for some more advanced computing hardware resources. And finally, there might be the lack of simulation software availability. Now, how to get out of these immediate challenges? There is one and only solution, that is a robust research network around the world with several industry, with several research laboratories, academic institutes. We need to get into some robust research networks. That is the only solution. So what is the takeaway from this presentation? First, Asia Pacific region is the fastest growing antenna market. Second, before we get involved into PhD research, postdoctoral, industry employment, or we plan for startup venture, we need to follow the current industry trends. And Gartner Hype Cycle helps in defining a trendy research area for antenna design. Some critical challenges may arise, but with robust networks around the world, we might be able to mitigate the challenges. So thank you everyone for listening to this presentation. Currently, our research group is focusing on the 5G, MIMO, the vehicle to anything antenna, biomedical antenna, and several other applications. So if you're interested, please visit www.sushomaya.live, or you may send an email to me, sushomaya.samanto@ieee.org. Also, we may get connected via LinkedIn. So wish you a Merry Christmas and a Happy New Year in ahead. Thank you.
Thank you so much for your nice talk, and really this would be very much helpful for undergraduate students and also for research scholars, those who are at the primary stage and they need to find their research problems. So, if there are any questions from on-site presentees or from virtual presentees, so I would like to take first one or two questions. Uh, I'm not seeing any more questions here. So, yeah. So, so thank you, Mr. Shamanto, for your wonderful talk. So, thank you so much. So, here with this. This is the end of our SBC session and also today's Young Scientist Conclave Program 2021. Now I request our EFT MTT chapter chair, Dr. Sujay Bishwar, to conclude this program.